All right, we are continuing. This is actually part 2 of the lesson. I just recorded a video because this is day 4 in our unit on working with exponents. We've been working with simplifying exponential expressions such as these, and we also learned how to solve exponential equations such as these. In the video just before this one, we did all of these problems. Man, look at all that stuff. But that video was getting too long, so I cut it. But now I have to do the rest of these problems. And so this is, I'm calling this part 2. So this is like day 4, part 2. Okay, so let's continue simplifying exponential expressions and eventually solving a few more exponential equations. If you didn't watch the first video, you should go back and watch part 1 before watching part 2. Okay, let me zoom in. When you have a power raised to a power, you multiply. So I'm really going to wind up multiplying both of these by -2. So that's going to give me m to the -6th power and v to the -8 power. Now, since both of these exponents are negative, I'm going to wind up dropping these variables down to the other side of the invisible fraction line. So this is going to become 1 over m to the 6th power, v to the 8th power. So that's the answer to number 20. Now, looking at number 21. Okay, no negative exponents, so this should be kind of easy. 3 times 7, we will multiply as usual, so that will be 21. Don't add just because we add exponents, all right? Regular numbers and exponents behave completely differently. 3 times 7 will always be 21. Meanwhile, n to the 4th power times n to the 3rd power is not n to the 12th power. It is n to the 7th power. Okay, that's how you multiply variables. You add those exponents. Now, p times p to the 5th power will be p to the 6th power. If you need to put a little 1 here, you know, do it. But it's a little silly because the truth is we have 5 p's over here and we have another p over there. Together that makes 6 p's. So that's your answer. All right, let's go back for number 22. Number 22, we've got just this little guy with a negative power is on the wrong side of the fraction, so we move it up. So that makes it 5n to the positive 4 power. That's all there is to that. Let's find number 23. All right, similar to the problem above where we got 21, 4 times 5, of course, is 20. When we multiply variables, we add the exponents. I would go ahead and do that now. So that will give me b, but -6 plus 2 is -4, so I'll have b to the -4 power. And then I will have c to the 3rd power, c squared and c. Now, here's my invisible fraction line that I need because I know I have to drop this one down because it has a negative exponent on it. Notice that the 20 stays put and the c to the 3rd power stays put. So just the b goes. So I will have b to the 4th power in the denominator. Okay, that's how you do number 23, guys. Let's find number 24. Okay. This is one of those, we're going to have to do the reciprocal. That's what I want you to watch out for. Anytime you have a negative power on a fraction, you're going to have to do the reciprocal of the fraction and make it a positive exponent. So this -2 is going to become a positive 2. But I'm going to have c to the 3rd power in the top and 5b in the bottom. So this is going to become c to the 6th power, because we multiply those. Am I going to multiply 5 times 2 and have 10? Oh no. This 5 is not an exponent. It's just a regular number, coefficient. So you have to do 5 to the 2nd power, like we always do. 5 to the 2nd power, that's 25. So please make sure you do that. And then, of course, b squared, just b to the 2nd power. Okay, so that's number 24. All right, number 25. Again, we just multiply. So negative 2 times 6 is negative 12. When we do these, we add these exponents. So x. Now, 5 plus negative 2 is 3. With the y's, we have negative 3 plus negative 2, that's negative 5. Here's my invisible fraction line. This is going to drop down. So I'm going to wind up having negative 12 x to the 3rd power over y to the 5th power. All right, that's number 25. How about number 26? All right, 26. There are no negative exponents, so I don't have to worry about that. 2 doesn't have anything to cancel with or simplify, so I'll just put down the 2. This n will cancel out one of these n's, so I'll have n to the 3rd power. These 3 p's will cancel out 3 of these p's, so I will have p to the 4th power. There's nothing left down here, and I don't need to put a 1 in the denominator, so this will be my final answer. Where's number 27? Uh-oh, 27. Where are you? Kabam! Okay. Be careful once again. If I ignore all this stuff, I have 4 to the 2nd power. So please make sure you put 16. Don't get caught up with all the multiplication and think it's going to be 8. It's not. Save your multiplication for these variables with their exponents. Power to a power you do multiply. So this will be x to the negative 6th power and y to the 10th power. Okay, here's my invisible fraction bar. This guy is going to have to drop down. So my final answer will be, I'll have 16 y to the 10th power over x to the 6th power. Okay, so there's 27. How about 28? Do I hear 28? Going once. Okay. This should be pretty easy. This is the only thing that's going to move because it has a negative power. So that's really it for this problem. That 3 stays up there. The x to the 4th power will drop down and become a positive 4 power. And that y squared stays there. It's traditional to put these in alphabetical order. So that's why I didn't go y squared and then x to the 4th power. I personally wouldn't mark it wrong if you wrote it backwards, but try to get in the habit of using alphabetical order whenever you can. That's tradition. So let's look for 29 and then 30. So there's 29. Okay, so we should be getting to be pros at this by now. If I take this and raise it to the 3rd power, negative 3 to the 3rd power is negative 27. Notice that the negative stays negative because this is an odd power. If this had been squared, this would have been a positive 9. All right, even powers will, a negative times a negative makes a positive. Anyway, on with the variable part. Negative 6 times 3 is negative 18. Negative 8 times 3 is negative 24. And then I've got p to the 3rd power. Here's my invisible fraction bar. These are the two things that must drop down because of the negative exponents. So that is going to give me negative 27 p to the third power over k to the 18th power n to the 24th power. So that is it for number 29. How about number 30? This is relatively simple. One way to do it is just to go ahead and multiply all of these. So that would give me n to the negative 3 power and p to the negative 2 power. These both have to drop down. So that would give me 1 over n to the third power p squared. So that would be the answer. Another way to think about this is if you have this negative power on the parentheses, you could just think of it as dropping this entire thing down. Okay? And so you could think of it as immediately becoming 1 over n to the third power p squared to the positive 1 power. And of course, then you realize, even before you write it, that you don't need the 1 and you don't need the parentheses. So you kind of immediately get this answer. All right, so that was a little more practice on simplifying exponential expressions. Now, 3 more problems about solving exponential equations. Okay, as we've discussed in the previous video, the bases need to be the same. I can't take this 2 and square it and turn this into a 4. Because 4 does not have the same value as 2. I'd be changing the value of the problem and it wouldn't be equal anymore. So that's a mistake a lot of kids make. Instead, what I can do is I can take the 4 and write it as 2 squared. See what I've done? I've taken out the 4 and I've written 2 squared, but did I really change anything? No, because 2 squared has the same value as 4, so it's okay. So the existing exponent I will keep. So this is 3x minus 3. And over here I can just keep this 2 to the x plus 4 power. Now I have like bases, 2 and 2. If the bases are the same, the exponents are going to be the same. That's the idea. But first let's go ahead and do the distributive property. So this is really 2 to the 6x minus 6 power. And this is really 2 to the x plus 4 power. Well, okay, that's the same thing. So since the bases are the same, the exponents will be the same. So I can go ahead and write 6x minus 6 is equal to x plus 4. If I subtract x from both sides, I get 5x minus 6 equals 4. If I add 6 to both sides, I get 5x equals 10. And if I divide both sides by 5, I get x equals 2. All right, and that is how you solve exponential equations. Let's do number 32. Now, 0.125. I really need to see this as a fraction. Let's use the calculator to be sure. So 0.125, if you go to your TI-30XS multi-view and type in 0.125, and then if you hit toggle and enter, you realize that that is 1/8. So we're going to use that. Okay, so I see the 8 coming because this is 1/8. So I'm not going to try to rewrite this as 2 to the third power or anything. I'll just use the 8. So I get to keep this as 8 to the 5x plus 9 power. Alright, and this is 1/8. But then I'll rewrite this as, so I have 8 to the 5x plus 9 power equals, and this is 8 to the negative 1 power. All right, not too bad. It's not too bad. So, if the bases are the same, the exponents are going to be the same. So I can go ahead and write 5x plus 9 is equal to negative 1. So if I just solve this and I'm done. So subtracting 9 from both sides gives me 5x equals negative 10. And then dividing both sides by 5, and I get that x is negative 2. All right, I think that is it for this lesson. Let me just zoom out. Nope, there's one more left. That's not it for this lesson. Okay, last one. Both of these can be written as base 3. So this one, I get to just keep the base 3. But this one, I need to rewrite as 3 squared. Now, the exponent that's already there, I will keep it. I'll put it in parentheses. And in a minute, I'm going to distribute. So I have 3 to the 9x power. But this is really 3 to the 8x plus 6 power. Since the bases are the same, I know the exponents will be the same. So 9x should equal 8x plus 6. Now, if I just go ahead and subtract 8x from both sides, that's going to give me x equals 6. All right, so that is a nice little review on how to simplify exponential expressions and how to solve exponential equations. I hope this video has been helpful to you. If so, a like is always appreciated. I will see you on the next video.